Alright, this is the Pythagorean Theorem, and then also the converse of Pythagorean Theorem. Okay, and in Pythagorean Theorem, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs, or this famous thing that you say a lot, math, a squared plus b squared equals c squared. The key thing that people forget is this only applies to right triangles here, so you need to have a right angle. Alright, now you got Pythagorean triples here, and this is kind of interesting here. Pythagorean triple, what that is where you have a set of side lengths, I guess, that make a right triangle. And here's the specific thing about these side lengths. These are all going to be integers. So we're thinking about like positive whole numbers in this case. And I got a couple of examples of these pulled up. So you have, like, for example, 3, 4, 5. That's a very common one that we see a lot. Sometimes you'll see this one, 5, 12, 13. 7, 24, 25. Every now and then we'll see that one, not as much. 8, 15, 17. Those are some of the common ones right there, and there's a bunch of other ones there, and you can go on the internet and Google them. Now also another example of like a 3, 4, 5 triangle, and by the way, remember that's going to make a right triangle, so like here's kind of what it would look like, the right angle. You could go and do Pythagorean Theorem and that would work out there. But anyways, you can also do scaled version of these right here. So like, for example, if I multiplied all these by 2, you'd have 6, 8, and then 10 right there. And that would also be a triple there. So you can also have scaled versions of these here. So sometimes it's useful to know some of these. So maybe when we see them, we kind of recognize them a little bit quicker. I don't even have most of them memorized here. I definitely have, 3, 4, 5, 6, 8, 10. We'll see that a lot. 5, 12, 13. Every now and then I can remember the 8, 15, 17. But I don't necessarily have every single one of those memorized. It does speed up the process, though. Alright, let's do a couple of examples here. Now this one right here, hopefully you see, it says find the length of the hypotenuse. I see 24 and 7, so it's actually going to be one of those triples. So I know x is going to be 25, but actually I'm going to show you here real quick just how to work it out. So you'd have x squared, or I'm sorry, we'd have 24 squared, a squared and b squared, and then equals x squared. Remember, your hypotenuse is always by itself on the equal side right there. So like on one side, either the left or right, but the hypotenuse is always by itself when you do the square of it. Alright, then I'm going to use a calculator here. 24 squared, it's going to be 576, and then plus 49, and then equals x squared. Alright, and then 576 plus 49 is 625, and then you can go square root of that, and that should get us 25. Now technically in algebra, when you square root both sides, you have to say plus or minus, but in this case in geometry we don't really have negative numbers, so we just talk about the positive version of this. 25, they didn't get us any units, so just 25 units there. Okay. Find the length of the hypotenuse of a right triangle. So this one, same thing, different numbers. So we're going to go x squared equals, I'm writing this backwards here, just the main idea is make sure x squared is by itself. So that'll be 81, that'll be 144, and then that will add up to 225. Squared, and then when you square root both sides, that'll get you 15. And then we could say 15 units, and that's all she wrote there. So that's a little bit of Pythagorean theorem. That's finding the hypotenuse. I think we have a couple of examples in a minute where we find maybe one of the legs instead of the hypotenuse. Here's a word problem. Find the length of the side of a square if the diagonal is 12. And I do think this comes up here in your homework. So it's saying the diagonal is 12 here. Now I don't know what the other two sides. Here's the thing though. It's a square, so whatever those two sides are, they better be the same. So I'm actually going to put x and x right there. This one's kind of weird here, so watch carefully. You got 12 squared and then equals x squared and then plus another x squared actually. Now typically, if this is a rectangle and we only had a diagonal, we wouldn't be able to solve this. But the key fact is this thing is a square. And you got two of these x squareds going on. So we're going to say 2x squared right there and then equals 144. Okay, and then after that, I guess we're going to divide by 2. So you'll get x squared equals 72. Now I think in the homework they're going to ask you to put these in simplest radical form, so we're going to break down most of these. So like 72, I guess you could go like 236, go 6 and 6, and you got a pair right there, so I'm going to say this is 6 square root of 2. And then what do we have? I guess they didn't give us units here, so I'll just put a little unit, little u there. So anyways, that's kind of working backwards, I guess, for one of the legs. We'll see it come up a little bit more here. And this one here, identify the unknown side as a leg or hypotenuse, then find the unknown side length of the triangle. Write your answer in simplest radical form. So this is all kind of the same stuff here. Notice this time we have an unknown leg right there, and we have another leg, and then you have a hypotenuse right there. So this actually sets up just a hair different. So I'm going to write this as x squared plus 16, and then plus 30, 16 squared, and then equals 34 squared. This might be a triple if I remember correctly, but we'll double check here. 16 squared is 256. 34 squared, I'm not really sure what that is. It's 1,156. Alright, so this is a little different here. We're trying to solve for the leg, so you actually have to isolate this x. So we're going to do that by subtracting 256 from both sides there, and that should get us, I think, 900. X squared is 900, and then I think that's 30 times 30 gets us 900. So x is going to be 30. And then I guess units. Okay, so that one happened to be a Pythagorean triple, or maybe it's a scaled version of a triple. We'll see here what's going on with number 2. Number 2, notice the hypotenuse is the unknown side. So you're going to go 6 squared plus 9 squared, and then equals x squared. Alright, so something like 36, and then plus, I guess, 81, and then equals x squared. What's that? 7... I think that's 117. Check there. Yep, 117. We can't square root that, so we'll just say it's the square root of 117. Now, if they ask us to round, like round to the nearest tenth or something like that, or approximate our answer, we would use our graphing calculator, whatever calculator you got, I guess, and get the decimal. Apparently, it's about 10.8. But they wanted our answer, I guess, in simplest radical form. So just, make sure you're paying attention to the format they want your answer in. Okay, more of the same. Looks like we don't have our hypotenuse, so that's by itself. X squared equals 20 squared. Oops. And then plus 48 squared. 20 squared, I know that to be 400. 48 squared, let's see. 2,304. So that's going to be something like 2704. Not sure if that is a perfect square. Make sure you type it in correctly too. Oh, actually, it winds up coming out pretty clean here. This one's going to be 52 units. So that one's actually not too bad. Let's see what's going on here on this one. You got 10, 50, and x. So we'll say 10 squared plus x squared, because that's a leg, and then equals 50 squared. Okay, so then that'll be x squared. This will be 100. And then 50 squared, I think that'll be 2500. We'll subtract the 100 and get 2400. And then we're going to start breaking this thing down. Okay, so I definitely see like 124. 24 over here, you can go 6, 4, 2, 2, and then 3, 2. 100, I'm going to break this down as 10 and 10, so I can go ahead and claim my pair right there. Okay, so you got a pair of 10s, you got a pair of 2s right there. Normally, you're supposed to break down the 10s, but they're going to both break down the 2 and 5 and 2 and 5, so then you just say 2 times 5, or 10. Alright, so let's see here. We got 10 times 2, and then times 3, and the 2 left over right here. Those are left over down there. Not enough to make a pair. So that'd be 20 and then square root 6 right there. So there you go. Now we can use Pythagorean Theorem to help us do other things. I guess like on number 3 here, find the area of the triangle. Well, remember your area formula is base times height and then divide by 2. But we don't know the height in this case. The height is always going vertical, or going perpendicular, I guess, to your base is what I should say there. So we're actually going to have to use Pythagorean Theorem again, and I'm going to highlight this triangle that we're going to use. Alright, and notice this side here is 50. Now, alright, so now I'm going to take this side right here, I'm going to divide it by 2. Going to get 14. We do that so we can go and find the height of the triangle here. We'll call that x. Alright, so Pythagorean Theorem will say x squared plus 14 squared equals 50 squared. Alright, then we'll get x squared, and then that'll be 196. And 50 squared is the 2500. Subtract 196 from both sides. That'll get you 2304. That actually comes out as a perfect square. And that'll be 48 for the height. And we're not done there. We're going to need to go take that 48 and we need to use that as our height for the triangle to go find the area. So we're going to go and do 28. Now remember, you want to take the entire base, not the base that we're dealing with beforehand, but we want to take that 28. So we'll go 28 times the 48 for the height. And then divide that by 2. When you do that, you get 672. And then don't forget your units. So feet squared. 672. Okay, use Pythagorean triple. Okay, use a Pythagorean triple to find the unknown side. So notice here, this looks really similar to a 3, 4, and then possibly a 5 triangle, except the sides are scaled by 10. But if we know that the ratio is kind of like a 3, 4, 5, then we can say it's 30, 40, and then 50 for this side length right there. And that actually speeds up the process a little bit there if you recognize those triples. Okay, next thing here, the legs of the triangle are 4 and 5 square root 3. What is the length? The hypotenuse. So I like this one here because it's asking, or it gives us a side length here in a simplest radical form first. So what we're going to do here is we're going to say 4 squared, and then we got to square the entire 5 squared to 3. Now if you had a calculator, I guess you could punch this out, using your calculator, but I'm going to show you where it comes from. Essentially this is like saying 5 squared to 3 times 5 squared to 3. Okay, oops, and that's 4 squared. And that's definitely not 8. There we go. Okay, so 5 times 5, we do the outside stuff with the outside stuff. That'd be 25. And then square root of 3 times square root of 3 is just regular 3. And then that's equal to x squared. Alright, so 5 times 5, and then square root of 3 times square root of 3. That's where you get those numbers there. Alright, so that'll be 75 equals x squared. Alright, and then that'll be 91 equals x squared. And if we're going simplest radical form, I don't think that breaks down. So we'll keep that as 91. Okay. Next section here, this is kind of used in, I guess, the converse of Pythagorean Theorem, and then we can do some extensions from this here. So, if you have, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides of the triangle, then the triangle is a right triangle. So you can verify if triangles are right or not. So we'll do that here real quick. I guess this here is 6 for a leg, 9 for the other, so we'll say 6 squared, and then 9 squared, and then we'll see if that's equal to 3 root 13 squared. Remember, when you're multiplying radicals, that's 3 root 13 times 3, and then root 13. And I guess I'll go ahead and start to simplify this. 36, 81. That's 117. 3 times 3 is going to be 9, and then 13 times 13 right there is 169. You can definitely see that this is going to be something larger than what we have here. Or actually, no. I'm messing up. This will be 9 times 13, actually. And actually, it's 117 happens to be the same here. So that one works out. Okay. Next one here, let's go verify if this next one's a right triangle. Make sure you use the legs. So we'll go 16 squared and then plus 24 squared. And we'll see if that's equal to 29 squared. I'm just going to type this in as one line in my calculator. 16 squared plus 24 squared. Apparently that gets you 832. And then 29 squared gets us 841. So it's kind of close, but not exactly. So this would not be a right triangle. Okay. And these are the extensions that you can do from these here. So you have theorem 10.4 and 10.3. You can use this to classify what type of triangles they are right here. So if the square of the length of the longest side of a triangle is less than the sum of the two squares of the lengths of the other two sides, then the triangle ABC is an acute triangle. Alright, here's how I remember it. If the c squared is smaller than the sum of the other two sides, then you have an acute. Then actually you're going to say, well, what if it is actually larger? You got another theorem for that. You're going to have an obtuse triangle. Remember, that means you have an angle that is actually larger than, with an angle larger than 90 degrees. Let me get my computer plugged in here before it dies. Alright, so we'll go ahead and apply those right there. I guess this is all the theorems side by side. Again, if it's equal to 90, it's a right. If this c squared right here, c squared is less than the sum, so that means smaller. I don't know why this isn't writing. There we go. Then you got acute. And then this one right here, you got an obtuse. If the c squared is larger. There's my phone going off. Turn that off here. Alright, so now we're going to go and classify a bunch of triangles here. I think there's, 9 examples here. So first of all, we need to do the triangle inequality theorem and then double check and make sure that 5 plus 12, the sum of those two shorter sides, is larger than the third side. Otherwise, we couldn't even make a triangle. So, of course, 17 is greater than 13, so that works out there. So now we're going to go and do the theorem that we just learned. We're going to take the c squared, or the longer side. We're going to figure out, is it greater than, is it less than, or maybe it's equal to the sum of the squares of the other two sides. So 13 squared, that's 169. 5 squared is 25. 12 squared is 144. When you add those, you do get 169. So we can say 169 equals 169. When that happens, you have a right triangle. Okay, this next one here. Notice you got square root of 8. I'm not exactly sure what that decimal is, so I need to go and use my calculator for it, and I already got it punched out here. It's about 2.8. So we're going to go and check 2.8, and the other small side is 4. That definitely is greater than 6. That's about 6.8. 6.8 is greater than 6, so we're good on that. We can make a triangle. So now what we're going to do is take your c squared. So we're going to say 6 squared. And then we'll see if it's equal. I'm not even sure if it's equal or not. Maybe it's less than, greater than. We're going to say 8 squared and then 4 squared. Now the 6 squared, that'll be 36. I'm not sure what goes right there as far as what sign. And then we'll say 8 and then plus 4 squared. 4 squared is 16. So then you got 36 blank, and then I guess that'll be 24 right there. So obviously 36, that's greater than 24. So since that's greater than, we have an obtuse triangle. Now actually, some people write the order a little bit different here, so let me show you how that looks. Greater than doesn't necessarily always mean an obtuse. Sometimes people get this backwards here. So I always just I always identify what's the c squared side right there. So 36, the c squared side is greater than the 24. But if you write it backwards, if you write it like this right here, as like for example 4 squared and then the square root of 8 squared, and then we don't know the sign, and then c squared, which was 6 squared, you're going to get all the same numbers, 16 plus 8 and 36. But notice how it's going to be backwards here. Oops. Notice here we're going to say that the sum of the sides is less than the c squared side. So what I usually do is determine what's the c squared side. The c squared side, that's over here on the right. If that's bigger, obtuse. If that's smaller, you have an acute, no matter which way you write it. So just identify where that c squared side is, determine is it bigger or smaller, and then go from there. Okay, next one here, let's go ahead and take a look. 20, 21, 28. So first of all, just double check. 20 plus 21, definitely greater than 28. So we're good to go there. So then we'll go and double check. And I'll go, I guess 28, I'm going to do the c squared stuff first. So we'll go 28 squared, blank, and then we'll see what 20 squared and then plus 21 squared is. Okay, so 28 squared. That'll be 784. I'm not sure what sign they use. Then actually, I'm just going to, just for time's sake, type this in as one line on my calculator, 20 squared plus 21 squared. Apparently, the sum of that is 841. So 784 is less than 841 right there. Here's your c squared stuff. It's smaller. If it's smaller, that means it's an acute. Then it's just more of the same after that. Okay, now I'm going to speed it up here a little bit. 15 plus 36, definitely greater than 39, so you can make a triangle. So we'll just go 15 squared. I'm going to do this backwards here, just once again to prove a point. Blank 39 squared. We got 15 squared plus 36 squared. Gets us 1521. And then 39 squared is also 1521. So that means they are equal. That means you have a right triangle. Okay, square root of 13. I think that's bigger than 2. Let's see. I mean, obviously it should be. Yeah, it's about 3.6. So 3.6 plus 10 is greater than 12, so you can make a triangle. So then we'll go, I'll do the reverse order here, or I guess the original order. 12 squared, square root of 13 squared, and then 10 squared. So that's 144. That'll be blank 13 plus 100. Oops. And then so 113 right there. All right, so your c squared stuff, that's larger. It's greater than, it's larger, so that will be obtuse. We got 1448. 14 plus 48 is greater than 50, so you can make a triangle. 14 squared, 48 squared, not sure, and then 50 squared. 14 squared plus 48 squared. Apparently that's going to get us about 2,500. And I know 50 squared is also 2,500. So those are equal, so this is right. A right triangle. It's just kind of more of the same after that. Here you got to be careful because some of you guys might jump and do the 10 squared and 12 squared and then check the 30 squared, and y'all might get some type of conclusion, but at the very beginning here, this one's kind of a special case. 10 plus 12 is not greater than 30. Therefore, you cannot even make a triangle. Now, you can do the Pythagorean Theorem converse here and go figure out if it could make a triangle, if it'd be obtuse or acute, but you can't close up the sides here, so actually this one here, you can't even make a triangle. So be careful on that. If you can't make a triangle, there's no point in doing the triangle Pythagorean Theorem converse to figure out the triangle classification. So just be kind of careful on that. This one here, you got 16, 30. 16 plus 30 is greater than 34. So let's go 34 squared. Let's compare that to 30 squared and then also 16 squared. 34 squared, 1156. 30 squared and then plus 16 squared. It's going to be also 1156. So those are equal. Got a right triangle. Okay, I think this is the last one here. 18 plus 34, definitely greater than 45. So then we'll go and verify everything. 45 squared, there's your c squared side. And then we'll go blank, 18 squared plus 34 squared. So this is 2025. 18 squared plus 34 squared is 1480. Alright, so your c squared side is larger. C squared is larger than you have an obtuse. And then you're done. I believe that is it. Yep.